last-second switch up on the schedule means that we are joined again by a familiar face. Luca, thank you for stepping in last second for us to close out day number 1 as our keynote speaker. It was an absolute pleasure to talk to you earlier, and I'm sure you're going to impart just as much wisdom this time around. In fact, I believe the subject is a word that even people who operate on Windows 98 have probably heard. It is, of course, the one and only Agile. So I'm going to let you get into it. Reminder to people, if you do have questions, Luca is a very friendly fella. Slap them in the Q&A section, and I'm sure he's more than willing to answer anything you have.
Thank you very much. So the topic of today is Agile cross-team collaboration and cross-team collaboration more in general. So if you are dealing with any form of cross-team collaboration and you want to know more about it, this is the right session for you. My name is Luca Minudel. I come from the north of Italy, and I'm a software developer by background. I have over 20 years of experience in software development and delivery. And I spent most of those years using lean and agile way of working and complexity thinking. During my career, I gradually shifted from software development to being a technical coach, and later I start mentoring managers, executives from the tech, product, and business side of the company. And now I call myself a full stack consultant, an advisor in lean, agile, and complexity. You find me on Mastodon, LinkedIn, also on Twitter. I'm quite active also in my own blog, and here are some of my publications. The Orange Book is the last one, and it's about practical application of human complexity in software development and digital products development. What are the goals of the session for me today? Well, first of all, I like to share with you 20 years of lessons learned around cross-team collaborations, lessons that I discuss with various experts. For example, from one of the author of Team Topologies and one of the author of Scaling Lean, and also co-creator of Less, and also with the co-author of the Agile Manifesto. And I also discuss this with other practitioners. So, why cross-team collaboration? Well, we all know that software and digital product development often requires the collaboration of multiple teams. This is when there is a single piece of work that needs 2 or more teams in order to get the work done. The root cause is sometimes dependencies across team. They can be technical dependencies. They can be product dependencies, knowledge dependencies, material, authority, and sometimes political, social, or economical dependencies. There are many common solutions nowadays in order to deal with cross-team dependencies, but ironically, none of these solutions cut it very well. A lot of people may start from traditional program management, try Scrum or Scrum, try some scaled framework, and then close the circle and go back from the beginning. Now, what is good cross-team collaboration? Well, when I have experienced good cross-team collaboration, it felt to me like in those good teams where team members feel engaged, productive, where you're continuously learning and improving and you love to go to work the next day. And it feels like if you have tried pair programming, mobbing, or ensemble programming, it feels like when you are doing that, you're doing it well, and people really enjoy doing that and continues learning. And once they try that, they really don't want to go back. So in the end, good cross-team collaboration feels exciting intellectually and socially. The admin, the planning, the coordination effort, they're very light, limited, don't feel overwhelming. There are very few delays, no waiting time, very few handoff, no back and forth of ticket and work, and no unproductive work. It feels enjoyable. without friction, and the work flow fast. So in the last 20 years, I studied, tried, and heard about a lot of different strategies on how to deal with cross-team collaboration. And all the strategies that I found out there boil down to two key elements. One is cross-team dependencies, and the other is the Conway's law. One of those strategies is about transcending cross-team dependency and the Conway law. What does it mean, transcend? It means doing things from an angle where they become irrelevant, or it seems that they become irrelevant. The second strategy that I found instead is about tackling cross-team dependency and embracing the Conway law. So transcending cross-team dependency is related to feature teams, if you heard about this before. Tackling cross-team dependencies has to do with team-level code ownership and is very well aligned to team topologies, if you read that book before. Both come with their own specific practices, How-Tos, and trade-off. Personally, I started here from transcending cross-team dependencies and Conway's law, a technique that involves collective code ownership. I will tell you more about that later. But then, when at some point I reached the boundary where this approach started to work well, and I started to look also into the other approach. Now, there is some learning about that the topic that we are discussing now, there are a lot about context and trade-offs and sweet spot. So it's not about choosing one of the two or believing that there is one solution for everything, but understanding what is your context, what are the trade-offs, and which option may work better for you. I would like to start to tell you more about the first strategy. I personally call it shared work because it's about sharing the work inside the team. And as I mentioned before, it's about transcending the dependency on the Conway's law. During 2000 and 2008, the best teams, especially those practicing Agile, used a lot this approach. They never felt the need for any scaled framework or program management because this approach was working extremely well for them. So the main point of this approach is simplicity. Simplicity achieved through mastery. This is when less is more and when you are adding by subtraction. This approach requires continuous learning between the team members inside the team and between different teams. So there is a constant learning and an ongoing change. For example, like continuous refactoring. Well, if you are doing continuous refactoring for real, you will have on your fingertips all the shortcuts of your refactoring tool. When you are pressing those shortcuts, you even don't know which individual keys you are actually stroking. You just do that because you have them in your memory, muscular memory. And this simplicity is not something that can be sold like a certification. It cannot be sold like a silver bullet, like a scaled framework, and it usually takes time to master. So it's something that you have to work out yourself and with the team day by day. That's why you will not find many people that talk to you about these, except actual practitioners like you and me that share knowledge and share what is actually working well for them. So let's get into the detail of shared work. What is shared work? Well, we have shared work when we receive an end-to-end customer-centric feature request, and the team is able to produce a running tested feature. The team can work across all components and all disciplines that are needed to get the end-to-end feature done. They have all the necessary knowledge and skill to implement it. And then all the teams can work on any any part of the product code base. So when we have a product, we have all the code base of that product, and any team can work on any part of it. They practice what is called shared product code ownership. Point one, make it so that there are no cross-team dependencies on people and expertise, because you don't have a backend team or a backend expert that can only do backend, or you don't have a front-end team, a DB team, a release team that create a knowledge silos. The point two, the shared code ownership, avoid the impact of technical dependencies, because every team, even when they have technical dependencies on another part of the code base, they can actually change it. Naturally, number two, put pressure on team and team members to make the code base easy to read, understand, to avoid unnecessary complexity like duplication or solving similar problems every time in a different way. And these, when practiced correctly, lead to good design and modularization, loose coupling, and lead to removing accidental dependencies and ultimately to technical excellence. So this is a secondary effect when shared work is working well. Now I mentioned knowledge silos. How knowledge silos happens, where they come from. And I find them very often nowadays in many teams. Well, it starts in a very simple way. When there is a new task, sometimes an individual or a team picks up that novel task, and afterward, all the similar tasks are assigned to the same individual because they already know how to do it, right? And this repeat again and again until only that individual is considered for that type of tasks and anyone else don't know how to do it. But this comes with huge hidden costs. We are creating a bottleneck, a single point of failure. When that person is on vacation, we cannot get that type of tasks done. When we try to distribute the workload inside the team, that also becomes very difficult because every individual can only do a certain type of tasks. And this, in the end, bring huge constraint on prioritization and planning. This is where companies sometimes try to employ a project manager to manage the situation. But in the end, most team end up having, and most team members end up having to multitask across multiple projects, doing a lot of parallel work and minimizing their productivity, not only damaging the team with the hidden costs that I mentioned before. So instead of leading to the generation of knowledge silos, we want and we prefer with shared work having generalizing specialists. So what is a generalizing specialist? Is someone that is very specialized in their own field, but also have a breadth of generalist knowledge that allow them to work in pair or work in group with other people to do tasks that are slightly outside his area of specialization. With generalizing specialists, when a skill is missing, this is when learning happens. Doing the work together. If you are a specialist, you will not pick up those tasks again and doing those tasks autonomously, but you will work in pair with other people and you will show them how to do it by doing the work. So especially specialists will act as a mentor to share their knowledge. Now, you may wonder, this is going to take time. Why should I spend time to share all this knowledge? Doesn't this make us go slower? Reality is that when I start to create that knowledge, when I start to remove that hidden costs, the team acquires speed, and that additional speed and productivity pay largely for the time invested in knowledge sharing. So it pay off and actually make the team goes much faster. So quickly recap, we are talking about long-standing teams that remain stable for 1 and a half. We have fully dedicated team member. We don't have X% full-time equivalent, part-time team member, and we have a cross-functional, cross-component team. What I'm talking about is referred to in the literature as a feature team. And their inventors, their creators of this idea that goes back around 2000, 2005 are Bas Vodde and Craig Larman. I had plenty and long conversation with Bas Vodde to compare his experience with mine. And I learned from him that he succeeded with this approach in many small and large organizations and with a lot of different teams. And the experience that he and other practitioners shared with me is congruent with my own. So I feel confident to point you out toward this solution as one possible approach. So how the planning work when we need to learn something for another team that is working with us inside the same product? Well, there are two options. In some situation, both teams not only share the code base, but share the backlog of the work to do, the prioritized list of the work to do. Indeed, you may know from the Agile literature, it is commonly referred to as product backlog. It has never been intended to be a team backlog. So both teams pull out the tasks from the backlog and they do the work. You see, in this setting, there is absolutely no additional work effort or change in the way of working required to deal with the work. In some cases, when the code base is very large or when you have multiple teams, sometimes a product is split into different product areas, and some type of task is preferably assigned to one team or the other. They are still have shared the ownership of the old product code base. They are still able to work on any item and tasks, but based on their ability and habit, they split the task between two different product areas dedicated to one or more teams. But when there is a common decision maker, all the priorities can be aligned and deconflicted. So this doesn't constitute a problem at all. Now, I told you about how the team help each other. And they can do this using two different strategies. One strategy is self-synchronization. So each team member simply help each other team member or member of another team spontaneously whenever it is needed in the way that fits them. This can happen during a refinement of some work to do, during a planning session, during the work. It happens in a very fluid and spontaneous manner. It is extremely efficient, lead to the emergence of an informal network between teams, and evolve over time. This approach is extremely good when you are dealing with work that has a high level of complexity. Imagine that you are doing something extremely new. The boundaries of the domain are still emerging. The interfaces between different modules, the APIs, are still emerging and changing quickly. And in this situation of high complexity and very changeable boundaries, this approach works very well. The other approach is called orchestration. Two members of each team are informed whenever some form of information sharing and help from one team and the other are needed, and they organize bringing the right people together. And then they get out of the way and let the people that need to help each other just simply do the work, help each other. Those people, the one that you see in the center doing the orchestration, are the opposite of a single point of contact or a man or woman in the middle. They simply facilitate the right people getting in touch. This approach works better with the medium low level of complexity, when the boundaries of the domain, the interfaces of the module are already emerged and are clear and stable. Now, in both cases, it's important to know that the coordination is also sustained. The coordination between the two teams is also sustained by closing the loop with the technology through continuous integration, frequent integration of the code, frequent build that are green, frequent releases. So there is a little upfront work and a little work that comes from actually integrating, building, and delivering. Okay. Now, I told you before that myself applying this, while I was applying shared work, at some point I started to hit some boundaries and I had to consider a different approach. Here I documented a few limits of shared work, boundaries that you can hit. Some limits are soft, easier to overcome, other are harder to overcome. But as in extreme programming, the idea is that I'm suggesting you to push the boundaries and see for real when things start to break down. Because most of the time in the industry and ourselves have the belief that some boundary cannot be overcome. But when we actually try, we learn that we can go much, much farther than we initially thought. So let me tell you about the soft limit, team maturity. Sometimes we have team that doesn't feel confident in applying this approach. But again, a key element of shared work is learning. So if we use that to learn the technique, to teach the techniques to the team, that can be easily overcome. And that has been done multiple times. Another possible limit is cross-cutting concern. When, for example, you have a feature that involves so many teams all together and you say, oh my God, I have to coordinate all these teams. And I'm back to the problem of dealing with cross-team dependencies because otherwise everyone is stepping on each other's foot. Imagine a work feature request like internationalization, accessibility, privacy, like GDPR in the European Union, where all the code base need to be changed and potentially all the teams need to work together. But again, even such a big change like that can be split and approached in a gradual way where one team at a time deal with it. And then the third limit can be politics and authority. This is when the company is organized in different departments and different teams may be driven by different managers. And so there is some politics and authority that can limit the collaboration across the silos. And this is where you may try to use influence and soft power to overcome those soft limits. Talking about harder limit, a common one is confidentiality. Sometimes organization that operates on a need-to-know basis as a default may find it hard, the idea that all the teams share all the knowledge around the product code base. But again, myself, I overcome this limit because there are legal ways that the company can protect themselves, and the real problem seldom come from the development team. A much harder problem is unlearnable skill. Imagine that you are working in a multi-domain environment where you don't only have a software developer, but you have specialists that can be mechanical engineer, electrical engineer, chemical, legal, manufacturing. So the type of skill that you cannot just learn working together with someone else, but you have to study them a few years before becoming a professional. Now, there are ways that these experts can work with the teams without becoming a bottleneck. And this can be overcome too. For example, making sure that one of them is assigned the full time, and other way that I will not discuss further now. The last is a problem that can occur when you're working with a different organization or a different branch of your company, and you find the partnership and the different culture making it harder to share the code base across those boundaries and agree common way of working. Why common way of working? Well, if one team that is working on the code base, for example, is maintaining and creating automated tests, and another team is changing the code without updating those tests, things will break down. If we are trying to gradually improve the design of the code base and we remove the technical debt, and instead another team is constantly cutting corners and adding more technical debt, we cannot work well together. So we need to agree a common way of working, and sometimes this can be different when we cross the boundary of a company and of a branch. So, as I mentioned before, when we reach some of the boundaries that you see here, in my own experience, I started to move and consider the second strategy. But from my personal experience, I would suggest to consider starting from the strategy number 1 to deal with cross-team dependencies, that is shared work, that I just explained. I experienced shared work multiple times, but it was very interesting when I experienced it while working for the Ferrari Formula One racing teams from 2006 and later. We had the two product areas with shared code ownership. One was track suite, so all application used by race engineer to prepare and to prepare the race, but mainly during the race, and a production suite dedicated to car design, production, quality control, and software that was used at the own factory mainly. And then we had two additional domains, vehicle dynamic simulation, a lot of physics and simulation there, and electronics, embedded electronics inside the car. We had about 3-4 feature team per product area, and all the teams shared the common cadence on refinement and planning, because we had self-synchronization inside the refinement and planning to help each other when needed. We had long-standing feature team and fully dedicated team members with the widespread use of pairing and pair rotation. As you can imagine, most of our applications were mission critical. We work in a fast-paced and high-pressure environment, and at the time we were strongly influenced by extreme programming and its technical practices like technical excellence, continuous integration, and elements of continuous delivery and trunk-based development. At the time, working in this way, we felt that we were stretched a little too much. We had a very large code base and a huge domain. So when someone was doing support on an area or on a product that they didn't know very well, they feel stretched and they had to ask for help often. But this big overview of the whole set of product and product area helping us a lot in being a good professional and in serving our customer better. Many years later, about 7 years later, some of the modules in this legacy code base started to develop very clear boundaries. We managed to remove a lot of technical debt accumulated through the years, and we could extract some of the modules whose boundaries and interfaces started to become pretty stable. And then we dedicated those modules to a specific team that they had a team level code ownership. And this happened after achieving a degree of technical excellence and clarifying and stabilizing the boundaries of those modules. So this is learning number 1 from this experience. And it is to constantly making code easier to read and understand while transcending dependencies with shared product code base ownership. The other is to create autonomy with long-standing feature team and generalizing specialists. And that is what worked well for us for a long time. At some point, I moved to strategy 2. So I would like to tell you more about this, what it is, strategy 2, and how it works. How can we collaborate across team by tackling cross-team dependencies and embracing the Conway law? So the two key elements of this approach revolve around the team topologies and team level code ownership. Let me clarify the language that I'm using here. I differentiate between essential dependencies and accidental dependencies. The essential ones are those that cannot be eliminated because they are an inherent part of the problem that we are dealing with. The accidental dependencies, instead, are those that has been added by mistakes, inexperience, lack of effort or quality, or because it was a temporary solution, or we cut the corner because we were in a hurry. And now those accidental dependencies should be removed. I also make a distinction between blocking team dependencies and non-blocking team dependencies. The blocking team dependencies, I define them in the same way that they've been defined in the book Team Topologies. So they are all the technical and non-technical cross-team dependencies and handoffs needed to complete a piece of work that force two or more teams to collaborate together and wait for each other to get the work done. It's like when you have to wait for a final quality assurance external team, when you have to wait for a database team, or when you have to wait for a DevOps team to do the manual release for you. So those are examples. Or when you have to make a change and you need an API to be changed, then you have to wait for the other team to make the change. So the major problem is when we have blocking essential dependencies and blocking accidental dependencies. And how do we solve the problem? Well, first of all, we need to remove all the accidental dependencies. You see that the green check and the orange, the green orange arrow and the orange check on the right side. And then we need to move the essential dependencies. We have to turn it from blocking to non-blocking. How can we turn a blocking team dependencies into a non-blocking? Well, we may automate something, a service that the team is providing. We can extract a service and a platform and give access through API and self-service, and we allow other teams to use it independently without manual intervention from another team. Many organizations mistakenly create bottlenecks, centralizing functions such as DB or DevOps teams, and that need to do a lot of manual work. So learning number one here is to start from cleaning up the mess. You see those two orange arrows. That is by far the most important learning. Most organizations, a lot of product managers that are not experienced in digital products don't know that eliminating dependencies is order of magnitude more convenient and faster than try to manage and accommodate them. So if you have just one learning for today to bring back, you should bring back this learning. Eliminate dependency. Don't document or accommodate them. Constantly remove them. Now, the other element is to create teams that are aligned to product area or to business stream of work, so that this will minimize the dependencies across team. And you can do that, apply the inverse Conway maneuver. creating stream-aligned team with the stream of business, for example, like the product area was mentioned before. And those teams, because of the Conway law, will tend to create an architecture that is aligned to them and have minimal dependencies across team. Now, even when you do what I just described, it will take some time for eliminating all accidental dependencies, for making all the blocking essential dependencies, shifting them into non-blocking. In the meanwhile, you will have some cross-team dependencies that you have to deal with. And I will quickly like to share with you some techniques and some options available. So I previously described to you a common backlog. That's one approach. A common decision maker with the product area, two distinct or more distinct product area backlog. We have a third option, a third situation we may find ourselves having two different teams that need to work together, but they belong to different disjoint entities, a different department, a different branch, a different organization, where the priorities are decided by different managers. And here, those managers that they have their goal, their priority, their bosses that are asking different things, they need to negotiate, often through a transactional negotiation, sometimes toward politics. They need to negotiate a way to align and deconflict their priority. Now, it's extremely important if you find yourself in this situation at the beginning of an initiative or a project or a program, you have to try to solve this from the beginning. Otherwise, it's going to be a huge pain and incredibly inefficient working with disaligned priority. The second option that you have to consider is how to collaborate. But sometimes, to avoid the problem, you can make temporary structural changes to the team. The best option is when you don't need to make any structural changes. Another option that is okay is when you have teams that have been together for 1.5 years or more. They have similar way of working, so some team member can easily move from one team to the other for the time needed to complete that ticket, that piece of work that require cross-team collaboration. Another option is to merge two teams for the time required to complete the work that require those two teams to collaborate together. That can be fine, even if it is not the preferred solution. But when the two teams together become too big, this can create inefficiency. The fourth option is to create a temporary task force. In this case, the temporary task force will be smaller, but this will require some additional setup, so that is the advantage. The third option to consider, I was mentioning before, is to coordinate the work. After you have planned the work and you start doing the work actually, how do you coordinate between two teams? How are you doing that? And how well is working for you now? Well, I personally hope it's working better than this. So let's see which option we have to make it work. We already mentioned before self-synchronization and orchestration. There is a third option that is a hierarchical approach, a strictly hierarchical approach. Now, this strictly hierarchical approach works very well when you're dealing with work that has a very low level of complexity, that is highly predictive and repetitive work. Otherwise, a hierarchical approach to team coordination, to coordinate the work, is very inefficient and slow down things, leading often to waste. The other option that you have to consider on how to manage cross-team collaboration is how to sequence the work. If our teams have to do some work together and this consists in a lot of tasks, how do we sequence our work? Well, again, I hope that you do better than them. And for that, I have for you 5 different options, different ways that I experienced through the years in order to sequence the work, going from the best at the top toward the bottom. So the best choice in my experience is what I call parallel work. This is where the green team and the blue team work in parallel in the piece of work that they need to complete together. In the same way that testers and developers can work in parallel, for example. So the team working on the client side can work in parallel with the team that is working to change the server side. Usually this is the fastest and most effective solution, but require very capable teams. The second approach is asynchronous blocking. So you have two teams taking care of the two different things, but using feature toggle, it really doesn't matter who finish first. Both teams can release into production, and only when both teams have done their piece of work, you can switch on the feature and it will be available into production. This actually eliminated the need for any coordination and remove complexity on the decisions related to the release. So that's also a good solution. Another alternative is staggered work. So, for example, you let the team working on the server side plan the work on the previous iteration, and then you do the client side on the following iteration after the server side has been completed. Another alternative is staggered with the buffer. So a buffer in between to make sure that if the green team is late, you still have some times and your plan will not be disrupted. So this gives some buffer to the green team in case they are late. The last alternative is planning using a deadline, fixing a deadline when the team will finish the work and the blue team will start the work. Actually, this is the more fragile approach, because when something goes late in terms of timeline planning, there usually is a domino effect and a lot of things start to go behind schedule. So it is unlikely to work. And this leads us to the third learning. The single most consequential success factor when working with the cross-team collaboration is the collaboration between teams and the way that teams actually interact. This is because the way that the complex system works is based on the interplay of many interactions between people and between teams. Note that most scaled framework, with an exception of less, they never discuss a lot collaboration and all the intangible things that are behind the human collaboration. They often discuss structure, role, and processes because they are easy to sell or to demo in order to sell a scaled framework, but they're actually not the relevant part for the success of cross-team collaboration. So what I'm suggesting you is to apply what we call the Agile approach, not only on the way that the teams work, but also on the way that teams collaborate, experimenting, learning, and then retrospecting on what is working well and what is not, and changing and improving the collaboration in an empirical way. What does it mean? This means when you start a cross-team collaboration to guess among the different options that I shared with you before, where it seems the best place to start, but don't spend too much time in order to do upfront guesswork. Pick the solution that seems better with you, start with the collaboration, do an iteration, and then do a retrospective to see what's working well, what not, and make the changes until you find a solution that is working well for you. So, in my personal experience, what it worked well for me in terms of aligning the priorities and the conflict in them is having a common decision maker. In terms of changing the structure is having a small gel team. In terms of coordination is self-synchronization. In terms of sequence, parallel work. And I use technical excellence to close the loop. Again, continuous code integration, trunk-based development, frequent build, code base always in a releasable state, and frequent releases that verify that actually the collaboration is producing something that work and fulfill the customer need. And that is a checkpoint, an arbit that is telling me that what we are doing is working well enough. So to finish with the last learning on collaborative work, team topologies, the top learning is that you always have to focus on cleaning the technical mess first and keep things clean thereafter in order to create a fast flow of work. After that is also fundamental to create a good frictionless cross-team collaboration, aligning team to the business value stream and constantly inspecting and adapting collaboration and removing any obstacle to cross-team collaboration. Before concluding my presentation and moving to comment and questions, I would like to share with you some of the trade-offs that I noticed between the approach of shared product code ownership on your left and streamlined product team code ownership or team topologies on the right. So I noticed that in terms of the impact of technical debt initially is lower when we use shared product code ownership because even if there are technical dependencies in the code base, one team can work on any part of that, and that doesn't lead me to a lot of cross-team collaboration. Instead, if I adopting the team code ownership, this at the beginning lead to a lot of cross-team collaboration, slowing down the work and make things extremely hard. In terms of consensus across team and departments, the consensus needed to make things work, well, that is very high in the shared product code ownership because all the teams that are sharing the product code base, they need to agree a lot of common way of working. Instead, with the team level code ownership, every team is more independent, so the need for this consensus is lower. In terms of risk of becoming too much a generalist and not having enough knowledge and understanding, and basically I'm talking about cognitive load, like discussing team topology, you have a medium risk in shared product code ownership because product area can help you with that. Well, on the right with the team topology, you have low to zero risk. And finally, in the terms of learning by doing, shared code ownership push you a lot, but there is also a push in team topologies because there is a push to learn across team. So here we are, a quick recap of the things that I already mentioned through this presentation. But what I would like to do now is to have some comment and questions, hear your experiences, and have specific questions on how to apply and combine these two type of working. So I'm calling back the host and see if we have some questions here.
Hey, thank you for that, Luca. Really insightful stuff. Yeah, guys, take advantage of this. There's a Q&A tab. Click across to it now. Type out your questions. I'll relay them to Luca. Really interesting stuff to cover there, Luca. I think one cool thing to kind of open on, we're talking this back and forth thing about shared versus collaborative work. Very early on, you mentioned that usually kind of the legalities get used as a blocker for why these things aren't feasible. Maybe you could speak a little bit more to that and how you overcome legal issues as usually a stopper. for progressing with those agile systems?
Well, actually, the solution is legal when you work in an organization that have intellectual property or privacy concern. You're asked to require an NDA, and lawyers allow you to make it safe for you to deal with that knowledge. So most of the time, it's fear. I don't know if you remember, there's been a problem between Ferrari and McLaren many years ago. Ferrari engineer moved to McLaren and copied some information. But it was one of the top managers at the time. Some of the teams working in some of the domain that I mentioned before, they didn't know some of the domain information because there was the fear that they could steal that information and share it with other teams. But actually, it was a top technician that shared that, one that had access to all the information. Later, we understood that it was better to share information. I organized some training between the racing engineer and the development team, and we started to work in a completely different way, more integrated. So it is feasible. It is absolutely feasible.
Yeah, it's a fair point, right? Like you see these contracts all the time, right? Like I think one of the classic ones that I experienced when I was a developer was this whole idea of even, and this is really popular in the game development side of things, is even if you have a project that you work on at home, your day job can claim ownership because the logic is that you might have been inspired by something you've done at work, right? So that's kind of a common nuance there, is to kind of navigate that legal side of things. I guess it's very hard to enforce as well in a lot of cases, right? Like at what point is it something that you own as part of your IP versus something that is of the person's own creative mindset, right? So to your point, it just seems more beneficial from the outro to just kind of be more transparent to avoid putting yourself in an awkward situation where you could have been actually 5 steps ahead, but instead you're 5 steps behind fighting legal battles.
Yes. Another of those false problem that is common is that in our industry we are very curious people, and we look at new solutions, and sometimes we forget the old one. Think about microservices. A couple of years ago, everything had to go to microservices. Now new literature is emerging how many problem microservices had. A decade ago, it was DLLs, and then we had the DLL hell. So we have this back and forth, but that is like being a fan of a football team. I like one team, you like the other, and we fight. But if we take our profession as a real profession, we learn to look at the context, pros and cons in every situation, what fits well the problem that we have in front of us, and inside that set of possible solutions, okay, which are the one that we like more, but inside of what works well for us.
Yeah, I think the classic adage I remember in creation is like you can have the best idea possible, but if you shelter it from everyone, it will wither and die, right? So that it's that whole point, that collaboration, that back and forth, that transparency probably allows you to get much further than you ever would, keeping everything behind closed doors. I think we have some questions coming through. We look at it. We've got one from Paul. It says, thanks to the keynote. Are there good practices to be able to identify accidental dependencies? Sometimes we might not always be aware because teams are already too used to a dependency being there.
Well, the biggest challenge that I found is when the code base and the teams are really put apart from each other. Well, there are organizations where you spend the whole day and you will not talk with the person sitting next to you for weeks or months. But there are situations where your development environment will not give you access to the code base of other modules. But in other organizations, instead, they may create an environment where you can download all the code, even of the components that you are referring to, into your computer. And then you can use the tools in your development environment to identify those dependencies. So I don't find the problem in the tools. Usually refactoring tools has the ability to find where a piece of code is used. They can analyze static code as well as dynamic code with dynamic typing. Usually the problem is having a development environment that give you access to the old code. So just to give you an idea, while I was working in Ferrari, we had some problem of some components that was indeed fragmented and moved apart from each other, but most of the problem were cross component. So what I have done, I brought everything into a shared solution where I could bring everything in the development environment and start to modify across the border until all the problems were solved. So it's a problem of access most of the time.
Okay.
And the second part is I have a friend of mine and many very experienced technical lead and engineer manager. The most things that they do, they walk across team, they listen what they are doing, and they share knowledge. So that's the second element that work around this problem.
Yeah. Okay. That's interesting. I think that maybe answered Jill's question as well. We do have one from Tamas. It's a classic one. I'm sure you heard this plenty in the past as well. Agile and Scrum work together, or are they way too different to implement together? Do they have to be kept separate?
Well, it depends. Agile is an umbrella term of many framework, Agile framework, and Scrum is one of those. But actually, if we are in software development, the most influential framework is extreme programming. If you look into the top tech company, their technical practices and the practices that nowadays we use, like a source code repository, continuous integration, test automation, they all come from extreme programming. So if I look back, I want to give you a suggestion. If I look back at the best teams I worked with, they took ideas from multiple frameworks based on what was good for them. Don't get married with one framework. The only hard decision usually is if you have a sprint or an hard iteration, or if you move to flow like in Kanban. And again, I give you a rule of thumb: when you are so fast to develop and deliver that you can really do that hand to hand more quickly than 1 week, that's the time to move to Kanban. When your iteration is 1 week and you cannot make it shorter, that is a good time where you move to Kanban. Those are all rule of thumb. Again, your context and your team is king, and I cannot do that without spending the day with you.
Yeah, I think that's a fair point, right? Is usually you hear people, their companies pick up these different methodologies, right? But it's almost like they're ticking a box as opposed to identifying what elements work from this and what are we actually truly creating. Because you might end up with, kind of an amalgamation of two or three different methodologies. I'm not going to say you're going to create your own one. There's so many of them at this point, but the point is, make sure that whatever you're implementing is intended to be used, right? Instead of just ticking a box.
Exactly. And that's the ticking box exercise, pretty common. At the beginning, Agile was created from developers for developers, and it was an absolute joy. Today, sometimes we face a fake Agile, what I call Agile theater, that is imposed to team, and we feel the pain because it doesn't work. So pay attention to good Agile, and if you want to start something, if you start reading a book on extreme programming, you never make a mistake.
And I think someone maybe it'd be helpful if we brought up this slide again. There was one slide earlier. Sorry, I'm going to make you cycle through for it.
Yeah.
It was the one where you had the five different methods with the different tiers along it for
Uh,
identifying based on I think it was Yeah, that's the one. So one thing I'm kind of curious with here, right, is like we have these work complexities and these team agilities and these different levels that are assigned. Obviously, like where you feel you're at may be a bit subjective, right? One team lead might think that our work complexity is medium, another one might think it's high. Do you recommend experimentation within both sides of where you would slot yourself? So, for example, if you think you're like in async blocking, would you recommend to experiment with both that staggered and parallel to see which one actually fits better?
So in term of complexity, what will happen? What will happen if things go wrong? Is that, for example, the team that is working on the client, the server, do the work, then the team working on the client do their work, and they realize that they need something different, and also the server need to change because they learned something that they did not know before, but not because they did not made enough effort to understand the code to look, because it was things that could only be learned by doing it. So the level of complexity hit you back when something goes wrong, no matter how hard you try, because you cannot predict upfront. So in this case, to make an example, parallel work allow you that if something goes wrong, you can immediately spot it, and the two teams can fix it in real time. Async blocking, well, you can turn on the feature, you realize it doesn't work, you turn it off, and then you fix it, a small problem. The staggered one may lead to a lot of rework, and you also face a lot of delays. So the time that you deal with that can be later. The staggered one, when you realize that you need to change something, the green team has already planned something else and will be available in 1 month. Good night for that. And if you find 10 problems, what does it become? 10 years before I'm joking, of course, I'm pushing the tangent here. But this, you get an idea of the complexity. In terms of agility, well, the more you go up, the more agility you need on the team, because the solution is flexible, but the skills required to work in that way require the team to have a higher level of agility
Okay.
to make it work well.
I think that's well explained. And then we did just get another one come in. I think this is an interesting one. They ask, "What are your thoughts on extreme go horse methodology?"
Sorry, say again. I may
Ex-
not know that one.
yeah, like I thought I was hoping you were gonna educate me here. Extreme go horse programming.
What is that? If the person that made the question can tell me a little more. I learned something new.
Yeah, I mean, I'm looking for it myself. Like, I found one article that opens up saying it's a satire of badly implemented agile and programmer behavior. We might have a joker on our hands. So I'm not familiar with that one myself. Um, but to kind of hop into a different question, one I was thinking about is what was it? Because I think we kind of covered most of them. Is that kind of idea of how we talked about these different methods that you can attempt. Obviously, what it's crucial to first identify what you think is going to work for you. It's another thing to actually realize whether it does. Is there kind of a recommended teething period like you like to go through, right? Like if you experiment with a new methodology, is there a certain amount of time as a minimum you like to give to see if it's working before you maybe try an alternative?
Well, um, it's really hard to understand how long you have to try something before you know if it is working or not. And then when it doesn't work, it's really hard to understand why it doesn't work. You only have the answer when it works, and when you are happy and say, okay, I would like to do this again. Not only I succeeded, but it felt good. Let's do it again. So since it's very hard, I usually use two techniques. So first, I do one small change at the time. I start where I am and I introduce a small change. So I have a baseline and I can see if I'm getting better from where they are or not. If I do a big change, it's really, it will take a longer time. If it fails, it will be extremely harder to understand what is the cause, and guessing how much time is needed is extremely difficult. So first things, I start from where I am and I do a small incremental change in a way that allow me to get feedback and learn from that. Sometimes that is not enough. If I feel that I need to learn more, I also ask experts sometimes. Those are the two tools. So when we were in Ferrari, and it's common for every team to reach what I call a plateau. They reach the best that they can do at the time. For example, for us, it was test automation, and a member from the famous Connextra team joined us and introduced a completely new technique to test automation that led to a completely new paradigm of design of the code. We were stuck at a plateau where we had some limitation and problems, and then we moved forward. So those are the two techniques that I use to deal with your question that is extremely difficult to answer, to predict the right answer.
That's fair. I think it comes back to that idea of being adaptive. And the beautiful thing about the way you kind of weave that final point is it feeds back into that early idea of access. So adaptability and access, right? Making sure that you're hearing everyone at the table and making sure that you're always willing to pivot. Because, you know, if there's one thing that we started off the day, this whole idea of failures are not a bad thing. It kind of fits in as we close out the day. You have to embrace what didn't work, figure out why it didn't, and then pivot correctly for your product. So
Correct.
I think, though, Luca, we've used so much of your time today. I mean, you've been incredible, my friend. It was a pleasure to have you
Thank
not
you very
just
much.
once, but twice. I mean, at this rate, I wouldn't be surprised if you turn up tomorrow somewhere. And I'm sure you'd have another subject ready for us, but we won't exhaust you too much. Luca, absolute pleasure, absolute privilege. Thank you for closing out day number 1, and I'll let you get on with your day.
Thank you, everyone. It was a pleasure. Bye.
All right, big thank you to Luca. You guys should have his contact details. You can see he's a wonderful person, absolutely receptive. Had great conversations with him. Would recommend that you do the same. Take advantage of these moments. Remember, these type of conferences are opportunities not just to listen, but also to be heard and to convey your experiences and get to deeper discussions than a simple host pleb like me could ever achieve. So make sure you take advantage of our speakers and everyone else who's in attendance. But that does bring us to a close for day number 1. Yes, I'm afraid it has to come to an end somewhere, but fear not, my friends, because this is only the first day. We've got tomorrow, and then we've got 2 days afterwards for an in-person event. But I'm getting ahead of myself. So we need to focus on this tomorrow. So as I round out, I want to give a big thank you not only to the likes of Luca, but every other speaker that has been participating, not just on this track, but the other 4. And in conjunction with that, my fellow hosts that were taking people through the talks on all those other channels. And they will return tomorrow for more insightful talks. But I think what we now need to do after a long day like this is give our brain a rest. So I'm going to say toodaloo, and hopefully I'll see you again, same time as today to kick off the show, which should be, for my time in Britland, it's going to be 8 a.m., which is incredibly early for me. I think for the in-person where this is taking place in Europe, it's like 10 a.m. So mark it in your calendars. Make sure you plan out what you want to listen to and maybe surprise yourself along the way. And remember to keep being active in the comments, right in these sessions, so you have a chance of winning some of those ebooks courtesy of our partner Packet. But I'm done with my rambling. Farewell, folks. Has been a pleasure, and I'll see you tomorrow.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and I am illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship ever stars. We don't need to say we're sorry. So where's the love?
This is all we got. Dreaming about a revolution in our minds. This is all we got. Talking about resolutions, getting high. We don't need a lot, and we don't care if we fuck it up. If it's what we got, then why not give it all we
I
got?
can see in your eyes you're defeated. Try to fool yourself till you believe it. That you better off, not men, I feel it. But there's a sky if you